Hello and welcome. I'm Shadow of Shadow Gaming, bringing you Programming with Shadow, episode 41. In today's lesson, we're going to continue with our refactor, but we're going to take a side adventure into LINQ. So, LINQ stands for Language Integrated Query. It's a way to ask questions of lists, arrays, anything that's enumerable based. So, what we're going to do is we're just going to take a few of these places and change them. So the approach we're doing here is called imperative programming. So we're telling the computer, okay, do this, do this, do this. So here we're saying the longest gets 0 for each window. For each window, find the longest. And we're setting it. Okay, so yeah, but we're telling it each step what to do. The LINQ goes a different route. It's called imperative. It says, it basically says, do this, that you don't tell it exactly how you do it. So how we're used to, we're declaring, we're saying, I mean, I've got that backwards. Imperative, we're saying, here, I want you to do this step, this step, this step. So backwards, so ignore what I previously said. That's imperative, that's what we've been doing. Declarative is what LINQ is going to do here for us. So we say what we want, and then let the computer figure it out. There's some trade-offs, but we're at least going to explore it a little bit for now. We'll go ahead and expand this out. I don't know if there's anything there, but for this one here, let's start with this one. So right here. Let's see if we can't clean this up. So I think we will be able to do something like this. Oh, first off, LINQ is a dependency. If you've noticed, I've been removing it, but what we can do is do this system.linq. So there gives us access. So now I'm just going to say return here. And we're going to return a registration window dot, let's see if it doesn't have a max. Just say, we'll do W to stand for window. W.count. I think that's all we will want. So all this is saying is find the max. And this is what we're going to use. So there it's the function, a selector. So it says this is how you select what the max is, and we say count property. I think that'll do it. So here it short circuits this. You can see this is unreachable. So let's just run it and let's make sure this works. But I think this is right. Just right off hand. I think that's all I want. Yep, that looks like it's working to me. So this is the one that caused it to, when it started shrinking, it didn't go out of the way. So let's see if it does that or not as well. But if so, that was really easy, because all we really had to do there was, can't show it, but you can see we don't have to do the loop anymore. We don't have to tell it what we're doing. Yep, there it shrunk back. So yeah, I think that worked. So good. So that is actually very good. So I'm saying that this is functionally equal to this. Functionally equivalent. Maybe not equal, maybe it doesn't do exactly the same thing, but say it does something there. Difference is here we have to know what we're doing, and you've seen before I was doing it myself, and then I added math.max to do the if check here. This pulls it all the way out, and now we're just saying, okay, I'll let the compiler figure it out, or the library. And you can make a case for which one. I think that one's actually more readable. Like in this case, you can have LINQ expressions or queries that aren't more readable in my opinion, but I think this one is. So all this is using is an extension. There it even says an extension method. I think we've talked about them, but if not, they're basically a way to say, take this IEnumerable, or IEnumerable is a list. List implements IEnumerable. If they show that. Not easily. But if you go look up a list, it'll implement IEnumerable, And that's all we're making use of here. We're making use of an extension method on it. So it's not really list or LINQ, it's just an extension of it. It just so happens to be in LINQ. So there, I think, as I said, I think that's clear. And we're saying, we're declaring, or we return the max from the value. And the thing to keep in mind there is that it's actually doing, it doesn't get around having to do this loop. It is doing the loop, but it's doing it internally. That's one thing to keep in mind. That can cause problems occasionally. Now I would argue that this method, if I would quit pressing that button, I would argue that this method should be an expression body method because it is social. There. There we go. This one can be too, but I don't like this one to be. See, if I look here, it can be an expression body member. And that's roughly the same readability, but I think slightly less. I think that's just slightly more readable in this specific case. The reason's because these are on multiple lines. If they were on short like that, I would, yeah, sure. But because they're not, I actually prefer this one to be not an expression body method. So let's look for another. There's some other instances in here we can use the LINQ. So get shortest registration line, very bottom. So this one's a little slightly different. I don't think we actually have to use LINQ for this. We can use LINQ, but I don't think we have to. So let's see. If I do, let's see if we can't do just very similar. Return registration windows dot find index. This gives us a predicate. So that's just what condition we're looking for, and we're looking for where window w dot count equals registration windows at, we can do min here. I think that'll get us the same. So let's break that down. So this is a predicate, so it basically is a Boolean, or true or false. So we're saying this, whatever method, whatever action, whatever lambda we pass in here, we're saying count equals this. The registration window.min is another one of them extension methods from this part is LINQ. This is LINQ. This isn't. This is actually built into the list. So this is a built-in function. So we're saying where count equals the minimum of the minimum window size. Window size is defined by count. That makes me think we should rename count there to be something more applicable, like number of registrants or something. But let's make sure this one works, and I'm pretty sure it does. Yeah, we'll go ahead and start this one and let it run. Yeah, it looks like it's running. It looks like the counts are good, so I'll let that run in the background, and let's take a look over here at registration windows. We're calling it count, and that's a good normal for what its purpose is, but we might make it a little more specific here. So yeah, I think we could just say do F2 registrants in line. That's longer, but I think that's clearer. And I even use max number in lines here, so I think that's more clear in the long run. Let's see if it ran. Says still looks normalish. Okay, there's just another one. So that one's definitely shorter. It's still long, but it's definitely shorter. Here we can make it a little clearer by doing this, I think. Yeah, now it at least fits on my view. We can at least see it. There's one thing we can do. We can actually make a little more use of LINQ if we want to. So let's see. Let's see if I can get this, because I may not be able to get this right. So here's just another attempt. So return registration windows. I'm going to do this on another line. So we're going to do an actual LINQ method. Select. This is another extension method LINQ provides. We're going to select. Let's do two things here. We'll say window and index. I think that'll work. Let's see. Here we'll need to make a new object. This is called an anonymous object if I can. It thinks it knows what I'm doing, so let's see if this works. Dot aggregate. Let's see. I remember how to aggregate. So up there, it actually doesn't help me, but I believe the first one's the accumulator, where you put something. The second one is where you what you're working against. Let's see. We'll say next window, maybe. Now this is a lambda. Next window dot. Changed the name, didn't I? Next window dot registrants on. Next here. Registration window. It should be register dot registrants in line. That isn't working. That's the min dot count. Yeah, wait a minute. Yeah, that isn't working. Yeah, I may have to actually read up on that one actually. Yeah. Oh well, we'll worry about that on at some other point. So what I was trying to do here was use actual LINQ method. So what aggregate's supposed to do is you accumulate over a sequence. So we'll actually do an actual lesson and actually look into how these are actually used. So there, if you read the thing, it says it returns the final accumulated value. So it would return whatever value we get, which should be the smallest in this case. So we loop over each one, take the minimum, we set a value into it, and then we keep going until we get the final value. The final value is whatever we set it to. But yeah, we'll look at that in an actual LINQ lesson. So we'll leave it at the other one for now. The other one's probably clearer for our purpose anyway. That I think is very readable. The one I was going for it, I think it would be readable eventually, but not just yet. Let's see. So I think there's one more find here. Yeah, it's finding the index. So again, this one's not going to be a LINQ query. What we could do we could make it one, but I don't think we need to. I think we can just do let's do this. So let's say int index equals registration windows find index. So there's a method. I don't know that I actually did use that before, but I don't know if we've actually looked at index directly, but it does what it says. It looks for an index based on the pattern you pass it in here. One too many quotes. So our pattern here is does the first match. So that gives us an index. So what it does, let's see if it says. If found, otherwise -1. So yeah, so if it doesn't find a value, it returns -1. So we can use that here. So if index equals -1, this is just our throw down here. Throw return index. Now I'm saying these are equivalent again. This one might possibly be better, but I have a feeling it does the exact same thing as we're looping over, so probably not a lot better. However, I think it's a little more readable. So now we're just saying we find the index, we throw if it's invalid, and we return. I think that's a little cleaner. I guess we should make sure that works, but I'm pretty sure it's going to. So save. Let's go ahead and start a run. There. So while it's running, it's incrementing correctly. So let's check for one more, see if there's one more for loop here. That's not one. So this one's not one. All this is doing is setting up the values. There might be a better way to do that. I'll have to think on that. But as far as readability, I think that's pretty readable. You're just setting up a new window. I don't care about that one. I was going to see if there's one more LINQ section. But I don't. Yeah. We'll leave it at that then. But yeah, so there's just a find, and let's make sure it worked. Did. Yep, that looks all right. So there's this little sneak peek into using the LINQ. So let's continue back what we were doing before that, which was we're doing some testing. So registration area is going to need some tests, so we'll go ahead and create that. I don't think I did already. So where's a registration area? It is a model. We'll add a class, registration area tests. I'm going to move it over here. I'm going to say public. And let's begin. The longest queue here. We'll start with it. So I'm going to say the rest of these don't have any logic, so I'm not going to worry about testing them at this point. If you do need to test them, you can, but there's not a lot of value in it. We'll say fact public void longest queue count. Wait a minute, it's a private set. Since it is private set, it's get only, so I can't easily test angle. So what we should do instead is use it as a test value here later. So let's cancel that. So let's move on to the next one. So here's the first bit of logic. So we set up windows. So we can test that actually. So this is in the constructor. So I'm going to say constructor sets up the correct number of windows. If you start having a if there, that's probably not a good time. So if you have if I have my third set a win, that's probably not a good sign for a constructor. So here we'll just say registration area system under test equals new, passing in number of windows. Let's say just so it's the 101 many. Expected registration duration 90. We don't actually. That one's a we don't care value. So there's our assert. That should create it. So here we should be able to say guess we don't really output that. Yeah, wait a minute. Can we check that? We may not be able to actually check. Okay, so good. Okay, so the reason I can't check that is we don't actually output that anywhere. Count of arrivals. There's no count here for number of windows. Once we create it, we're assuming we created it correctly, which that means the registration area is actually correctly hiding that value. So the outside doesn't actually need that value. So I think that means we don't need to test it through this method either. I think that needs to be done elsewhere. But there, I think that's another test that I don't think is actually needed. So I think we can say, okay, there's nothing here. Here, I'm not going to test this one yet. I still think I can remove this. That's not internal yet. Not internal yet. Still feel like we'll be able to make that internal eventually. All right, find longest queue. So that one, maybe this will be the first one we can actually test. So find longest queue. Returns the longest. So we may have a little bit of setup on this guy. Number of windows, let's say the number of windows is 7. I think that's our default. Longest queue. No, find longest queue. Let's change the name. Let's make that find length longest queue. Let's do there. I think that's a little cleaner from the name. Let's make sure that builds. Let's make sure we renamed it properly, but I think that's a little clearer on the name. Now this is long enough. I'm going to say down here, just so we can see it. So yeah, so it built. I think the test will still run. So yeah. All right, so we're good. Okay, let's start this. Returns 0 when there are no registrants. Or actual equals 0 equals actual. There's just a test. There's one. Fact public void no longer find longest queue. It's this, which is a longer name, but I think it's clearer. Still might like it to be find actually. So let's do one more adjustment. Find longest count of registrants returns the longest, returns the correct count. I don't think there's anything to say there, so we'll leave off the when here. So let's copy this. Trying to make sure I think of a good way to test this. So soup.add arrival. It's not a good name there. So arrival there probably should be something more like a verb. Maybe arrives is a better name. So registration area, and then somebody and registrant arrives. That might make better sense. I don't like registrant arrives because it's in the parameter here. So we'll say new registrant 42, new event, arrival, date time.now, 42. There's this one, so the count should be 1 at that. Let's just make sure that works first. When there is 1 registrant. Where's the correct count? And there are many registrants. So how we can do that, let's just loop this, I believe. So for let's do int I equals 0, I less than 42, I plus plus. So there added a bunch of arrivals. So here it's going to be a problem. How do we predict where those end up? This may not actually work because we hit it. We hit F9 here, run, debug this test. We do F10 to step over, we get 6. We rerun this test. Get 6. Okay, that might be okay. But since we're never actually handling a departure, I guess this does work. What I was afraid of is that it's not going to be consistent. So here we got 7 lines and we divide by 42, so that makes sense. We're 42 divided by 7 and we get 6. Okay, so that makes sense. So we'll say count here equals 42 divided by 7, which should pass. What we can actually do here, though, do a const int number of windows equals 7. Let's remove some magic numbers. Const int number of registrants 42. With some magic numbers. One more magic number. Const int does not matter equals 19. We'll just say 0. So there's just removed a lot of magic numbers. Let's make sure it still runs, because we're going to try to pull that up into a theory next. There we go. So now we got it more generic. Make it a little bigger. ID, and we'll just put the ID as 42 bucks. Okay, so there, so it still works. Let's see if we can't make this a theory now. So if we remember, a theory lets us pass in values. So we have inline data. We'll pass in That's in 7, 42, and result is 42 divided by an evaluation. I don't know if we can do an evaluation up there. It may have to be constant. Either way, let's see. We pass in int number of windows, int number of registrants, double expected value. Okay, that does look like it works. So let's make this a little more readable. We'll do that. Now we can cut these. I think we still have a passing test at this point. So instead of this, though, we need. Oh, we're already doing it. So yeah, we can just drop this. And there, now we're in control. So now we can copy this line. We can say number of windows is 7, 0. Yeah, a place for a bug, but this is in test code, so it's all right, I think. This is our first condition. There's no registrants. Hit 0. Here, let's do a 1. So now there's 1. Now the length should be 1. And it doesn't work on this one. So let's see, what does that give us? Doesn't it say? Expected 0 got 1. And that makes sense because we're doing the whole thing. I think it'd always be round up because they're whole people. So we'll see math dot ceiling. And I cast this to double. How does this work? Okay, so that works. So we can't have a 0 for the first value. That just doesn't work. Let's do one more value here. Let's say something odd. Then we have 9 windows of 2 and see if that equals out. So that should make the longest what? 8. Yeah, I don't like that. I don't like doing the math here, so let's do it ourselves. We'll do expected. We will say double expected. Say int expected. Like that. Now we will say comma 0, comma 1, comma 6, comma 8. The reason that's 8 is it's 45 would be a bunch of even rows. It is not 5. Yeah, I can't do math. So 45 would be 5. Each line has 5 in it. So yeah, that makes sense. If we drop this from 42 to what, 39 times table 27. I cannot do math while I'm thinking. So let's see. So if we wanted that to be 4, 45, 45 minus 9, 46, 36, sorry. That should now only be a 4, so this one should fail. Fails. 4, yeah. Okay, so yeah, so I think that's working. So there, I think there's just a test. Now we don't need these two. I think that's an alright test. So now we're testing this condition and with several conditions. That gets us the longest queue count. All right, let's look at some of these other methods. Handle event, that's the big one. All right, so let's do it. So we'll do fact. We'll do an arrival event first. We'll do the throw event first. Public void handle event throws invalid operation exception when not given an expected event. So here we'll do registration area. Soot equals new. Number of windows, we'll say 7. We do this, let's see. Do a mention registration dot default number of windows. There we go. Value duration. There we go. We'll do that. We'll set those as the default values. Now, for handle event, we just need to give it a bad event. So we'll say assert throws valid operation exception. A dot handle event for ex equals that. So there's our exception. Ex dot message. Now assert equals whatever this says. Message. There's what we want for this about. Delegate does not pick one option. What? So we have a test that does that already. Let me check. Maybe messing up the syntax. valid operation except A. A is the method. So we'll pull it out like we did there, but I don't think that'll help. Void A dot handle event. Oh, there's the problem. Null. A. There we go. The problem was I was calling A instead of system under test. This should succeed because null's not valid. I guess we get null reference in that case though. Yeah, null reference, so we should fix that because that is a possibility. That's annoying. If current is null. So here, this is an annoyance. So when you do the you're asserting that this can't be null because we don't have a that. It's not technically the case. You can force it through like we just did. So in this one, it's really easy because it's an event. So event was a enum or event type here. Event's actually a class, so yeah. So maybe that's not the either way, let's say here that it's a special handling. So here we can get back to a test. So now this should work. We give it special handling here because oh, where did it fail? We'll just say null here. There we go. And now, if we run the test, we should see another failure. I need to actually specify what we're seeing here. And now. Okay, so set that up to be a theory, so we'll just go ahead and switch that to theory, inline data. So we'll pass in null, then we'll pass in, we'll just say 3 because 3 is the first value. Now we have int, valid event. So reason we're passing in an int is because we're going to do this. So event, valid event. Oh, wait a minute. This is not going to work. Okay, never mind. Let's hold off on that. So let's revert this back to the null. So that's actually a special case. So we are going to have to handle that separately. Event is null. Now we can copy this and let's add an actual event. Not a valid type. Now we can do that. So now instead of this, we'll pass in a new event type. We'll say 2. Date time is valid, so we'll just say now, and ID is 0. 2 is not valid here, but we can fix that. We can say event type. And there, now it's valid. Now 2 is a null. Now what did I? It's another one of them. Let's try that again. Now if we run it, that fails. Event 2. Okay. But it does a toString of the event though. That don't think that's what I want. Current dot type. Let's do this instead. Event not recognized. Now we don't even need to do that, so we'll just say event not recognized. Because from a user's perspective, that's not going to make any sense. So for our perspective, if we get that event, we know where it ended up at. I think that'll be all right. Here we can even say this is event is not. Again, we know where that's coming from. Event is null. Now, if we run these two, let's see what. Good. And good. So the reason I didn't do I changed the message there is I don't think that message is ever going to make sense. Because it's always going to be a number, and for a user perspective, it's not going to make sense for them. In that case, it's not a user. The user doesn't get to enter the event. The system's entering the event, so that means it made a mistake. So I think that's a better situation. So let's do a fact here. Public void handle event handle event supports variables. We'll start there. We'll copy this just so we don't have to type in all the defaults. Alright, so handle event. So we need a valid event, so we'll this whole thing. Event though is now a event type dot arrival. So now we should have handled that properly, and what that should give us out is next event with an arrival. Should give us a departure. So far, result equals. Now we should be able to say assert dot equal assert dot not null result assert dot equal event type dot departure result dot type. We could say something with the time. I'm not going to say something with the time though. Let's set this to const int registrant ID equals 42. Now we'll set a registrant ID. We should get that out as well. Assert dot equals. I'm not going to worry about the time because the time is really hard to actually keep track of. Guess what we could do? Maybe we could make sure it's set, because I think that should be set. Nah, we'll leave that as is. So there, we handle an arrival when the queues are empty. Let's add another one. Let's do another arrival. What's arrival? when there are at least one person in each queue. So here we will do this, but we will say, instead of default number of windows, we will say 1 const in number of windows equals 1. Number of windows. So now we'll add one. We'll add one, but we'll add another ID. Now we should get the second one out, and it should, or we should get a null here. Insert null. These two should fail. The reason that's null is because we already added one. So the second time there we go. There's just two tests. There's some stuff in here. Technically, we actually just covered that, but we'll keep going for the moment. So let's handle the departure. Public void handle event supports departures when the queues are empty. So this is just saying it doesn't throw, basically. Here we'll just copy this one. Here we're not actually adding anything. So var result equals dot handle event new event type departure date time dot now registrant ID. So here this one should be null because there's no registrant. Might possibly throw, we'll see. I don't remember exactly how I've handled this, throws or not. All that's doing, let's go down here. So here the peak fail. Yeah, it failed. Yeah, registrant not found in any. Good. That means we did handle this case, so good. I wasn't actually sure. Throws when departing with no registrants. So let's grab that instead. We'll do like we did that before. We'll say void a create this little method there. Var ex equals assert throws invalid a assert dot equals no registrant ex dot message. I know that's not the right message. I've already forgotten what the message was. Yeah, it's no longer there. Let's just check that really quickly. Strings differ. See, there's just a typo actually. Let's find that. No, it is not a typo. It is the preview wasn't right. So there we go. We can get rid of that line. There's this test. That's a good one because that was the case I actually thought I'd probably missed, but I did not. Handle event. Supports departures when there is a guest departed. Now, copy this one again. Now we add one to the queue. Now we'll say var actual equals, and now let's do it like this. This one can be, we can not care about that one. Var result equals dot handle event. We'll pass in a new event of departure, date time dot now, registrant ID. There we go. So there's this result. Result should be null. It should be done, but it should not throw. So let's make sure this works. The reason it should be null there is that when we do a departure, if there's no one there, if there's no one else in line, we don't do anything. If there is somebody in line, we output them, or we return that. So now if we copy this one, we should be able to finish this with make this one say turns null when a guest is departing and no other guests are in the queue. We'll do the same thing here. Return next departure event. There is a guest departing and another guest is in line. All right, so we'll add 2 here. Yeah, we'll just do this twice. I was debating how I wanted to do that, but here, say not null, assert dot equals date time event type dot departure result dot event type assert dot equal ID registrant ID, just like that. Let's see if this one works. It did not, so what happens? Value is null. Oh, this is because we have multiple windows, so here we'll just say one window. We'll do const int number of windows. That way they both join the same line, equal 1. Now if we run that, it should be good. There we go. Now if we run all tests, we should see them on. Here. 5 and 1 failed. 9, 46. Instead of 46, it was 43, wasn't it? Right. There we go. Okay, I don't know how I changed that, but that worked. All right, so there's just a couple more tests. So let's see. Here, we'll say returns null. Returns reporting event. Departure event. There we go. I think that's a little better. I can say throws invalid operation exception. Okay, so there's just a little more coverage. So that covers this method here. handle event. Also covers handle arrival, handle departure, arrival here. Let's do this. Let's do soot dot handle event new event type dot arrival date time dot now and 42. Now let's comment this one out. Make sure those still run. Okay, they still run. So let's get rid of that. So now that updates. No longer does that. Let's see if that goes away. Either way, that's no longer used. That's used in one spot here. What we can now say is these are private. Private. That's nice because now we say clean and rebuild. Now it ran. We can run these. Now if we run the simulation, we should see the simulation still works. What we just did there is called encapsulation. We're encapsulating some action here, the handle events, the arrival, because we don't do anything with it. In fact, we might can be able to pull them up on out as well. That worked. So let's look at that really quickly before we finish. Handle arrival. What does this do? It creates a new arrival event. Now it creates a new registrant. Instead of that, I could just say event and create the registrant inside. Let's pull that up. So this is an event, arrival event. Now, var registrant equals new arrival event dot registrant ID and arrival event. New registrant. Now I think that'll just work. We no longer need this. So say arrival. Now this method goes away. So now if we run our tests, I think we'll see all the tests succeed. Here we'll just pull method out. Okay, C, run. So here we have a success. All right, so that's working. We'll stop that. Here we'll run our tests and they work. We're good. So there's just an arrival. So now we lost a little more method here. We'll change this name, so we'll say this is handle arrival. So handle departure, it does even less. So yeah, it just passes the event ID. Instead, we'll just pass the event. Pass current, we'll call this handle departure. We'll pass in event. Current event. Now we will say current event dot the registrant ID. Now we can comment this guy out, or I guess. Now we should see all the tests run. And they do. We should see the actual run here work. And it looks like it does. So There, so now we shrunk that out. So now we even got rid of two more helper methods that didn't really do anything. So now we've got those two. Got these. These are private. These are private and don't do anything, so I can probably pull them up and no need to worry about them anymore. This one probably keeps separate, actually. Yeah, find. What I could do there is I could pull that up into an internal method. Let's see if it ran. Like a success. So yeah, so let's go ahead and do that while we're here. So we'll say here. Here with just window index. Now we don't need that method. Here for peak, it's just the exact same thing. So it's registration window at index peak. There, we don't need it. Oh. Oops. Make that an indexer. There we go. So there's just two more methods we don't need. Find here. So find we do need, but we can do it like this. That's a little cleaner for what we're doing here. And what we can see is this runs now. And it's good. Schedule service for registrants. We still use that in two places, and I don't think I want to try to impact it any. Yeah, I don't want to try to do anything to it just yet. We may still in the future, but maybe not right yet. This isn't used either, so I'll tell you what, let's do this. We'll copy this. Here, we'll keep that, but we'll do it in an internal one as well. Then we can get rid of this. And now we have get shortest line, only used here in arrivals. Here we have a find, it's only used in the departure, so it's only used where it is. And this one private method that we actually have is used in two places. This private method handle departure, only used once. This one here. I want to keep them separate because they're bigger, but we could put them as ones here as well. That would work as well, so we could do that. Let's run the test again. Didn't break anything. Okay, I think I like that. So now we've tested all this code. What we are now missing is this schedule. So if there's anything important happening here, there's some duration code in here, so we may need to make some adjustments and test that. What it's doing, setting longest and shortest duration. So here's what we'll do. Let's do a to-do test setting of durations. Those will be handled in the handle event because it's the public method here. So what we'll need to do is actually go through and check if we want to add another condition here to see what those set are. Maybe we want to do them as a separate test. After that, now we may need to do that. No, we got that message. So yeah, maybe after those two, maybe that's all we actually need because then we'll have the total duration. Yeah, that may be the only two tests. So that may be all of the testing we actually have in here. So there may be a couple more tests to handle duration there. Maybe it. Get rid of that. I did not want to use reflection in this case. Move unnecessary. All right. So there we go. So there's just some more tests. So we'll close with this then. So we're getting very, very close now. So we'll do that cleanup next time. We'll finish those tests, and then we'll go over here and actually look at our final to-dos over here. I think we're about out of to-dos as well, so that'll be for next time. So thanks for watching. This has been Programming with Shadow, episode 41, and we'll close it here. Thanks for watching, and have a wonderful day.